The next thing we need to talk about are reference frames. Physics is based on observation and measurement. In order to measure something, it has to be compared against something else. Let's take an example to show how the importance of choosing what this something else is. Imagine a person is in a bus and walked from the back of the bus to the front in 5 seconds. Another person sitting in the bus had a tape measure and measured how far he walked and came up with 10 meters. Now let's go outside the bus. A bystander watched the walker and observed that by the time he finished his walk, he had covered a distance of 100 meters as measured from the traffic light to the bus stop where the bus stopped to let him off. How can the same person walk both 10 meters and 100 meters at the same time? That's the concept of a reference frame. The reference frame is a system in which measurements are taken, and the reference frame can be stationary, accelerating, or moving at a constant velocity. Your measurement depends on which reference frame you're using. In the bus reference frame, the walker covered 10 meters, but in a reference frame attached to the Earth, he covered 100 meters. And if you use a reference frame attached to the Sun, the same person covered a distance of 149,000 meters. Why is the last distance so great? Because the Earth is rotating about the Sun at a tangential velocity of 29,900 meters per second. So in 5 seconds, if you were sitting on the Sun, you would see the bus driver covered a distance of 29,900 meters per second times 5 seconds, which is 149,000 meters. Can you think of other reference frames that would give you a different measured difference? Remember, just like the Earth is moving about the Sun is also moving. So some of those reference frames might be things like a star system, nebula, galaxy, cluster, supercluster, and so on. There is a special kind of reference frame. It's called an inertial reference frame, and it is special in that Newton's first law of motion is valid. In other words, an object in such a reference frame will only accelerate if a net non-zero external force is applied. It's a frame that is moving at a constant velocity, which includes a frame at rest, since 0 meters per second is a constant velocity. Accelerating reference frames are not inertial reference frames. Reference frames attached to a bus that is increasing its speed, or to a merry-go-round are not inertial reference frames. Why is this? Take the case of the bus. If a golf ball is in the aisle at the front of the bus and the bus accelerates from a stop sign, what would the golf ball do? Well, of course, you'd see it move backwards down the aisle without anybody applying a force to it. If you're on a merry-go-round and you throw a ball across the merry-go-round to your friend, she sees the ball curve away without any force pushing it to the side. So clearly, Newton's first law isn't working here.